This is an 18.2a assignment. We don't really have any notes today, even though it's sort of a new section. If we were in class, we would have been doing this review assignment and starting on a project. We don't get to do our project this year because we're not in school. So you have a couple of days of 18.2 instead of 18.1, but they're really a mix of 18.1 and 18.0 stuff. This is just a lot of multiply fractions and then trying to understand the patterns that go with this. So we're just going to pick out a couple of these problems and work them. The whole left-hand column of your page is just multiplying. And then we're going to deal with filling in some from the right and see what happens. I'm going to try and pick some even ones. Notice that this whole first section here is multiplied by 12s, 1 12, 2 12, 3 12s, 4 12s, 5 12s, all that stuff. Because if you took the unit circle, which 2 pi is a full circle, and split it up into 12 parts, you're going to get all these numbers. So every answer here is an answer that you will see in the unit circle that we drew on our 18.1 notes. Let's do number 4. We have 2 pi over 1, and every one of them starts with 2 pi, times 3 twelfths. And I want to reduce that so I can work this out. So I'm going to say 2 goes in there once, 2 goes in there 6 times. I can reduce up and down too. 3 goes in there once, 3 goes in there 2 times. This turns into pi over 2. That is the answer to that problem. Let's do another one. Another even one. Let's look at number 8. I'm going to cross cancel again. 2 goes in there once, 2 goes in there 6 times. I'm not going to reduce any more than that. So the top is 7 pi, bottom is 6. 7 pi over 6. How about one a little further down? How about number 11? Ooh, I don't want to do 11. Yeah, I want to do 11. I need an odd one because I'm looking for a certain thing. So I'm going to say 2 goes in there once, 2 goes in there 6 times. Notice that's happening every single time. Then I can do 2 goes in there 5 times, 2 goes in there 3 times, and I end up with 5 pi over 3. And if you didn't like all that cross-canceling, it would actually work to just say 2 times 10, 20 pi, 1 times 12, 12, and then reduce that down to 5 pi over 3. It still would have worked out for you. Then I'm going to look over here at the right-hand side and see what this says. Number 23 says, find all the answers from 1 through 22 that reduce down to a denominator of 2. Here's one of those things. So I'm going to say, what if I grab pi over 2 and put it in that space? I didn't work out any others that have a denominator of 2, but you can be pretty sure that somewhere down that column there's going to be another one because I have 2 spaces for it. And convert it into degrees. Remember that if we want to convert from degrees to radians or radians to degrees, we're going to use 180 over pi or pi over 180. In this case, we're starting with the pi and we want to get rid of it. So we're going to be using times 180 over pi. And that is 180 degrees. I'm going to cross out my pi's, and I'm going to say 2 goes into 180 90 times. Answer to this is 90 degrees. This problem is also going to ask us to find the reference angle from that. So I'm going to sketch a picture here, but you don't have to sketch a picture. You can look at the circles from your notes. But I'm going to say, if this is at 90 degrees, the question is, how far is it to the nearest part of the x-axis? Well, this is a unique situation because it's 90 degrees to that one, it's 90 degrees to that one. My reference angle is just 90 degrees. You could do that in radians if you want to, but you're required to convert it into degrees anyway. When you check this, 1 point, 1 point, 1 point, 1 point here, and when I find the other one that's pi over 2, that will be another point. But I'm counting this as 1 point, even though you kind of had to put down 2 answers to get there. This was just a process to get us to that spot. Let's see, we have one with a denominator of 6. I don't have a space for that, it's on the next page. We have one with a denominator of 3. So I'm going to say, find all the answers from 1 through 22 that reduce to a denominator of 3. I'm going to write down my 5 pi over 3. And I want to get rid of the pi, so I'm multiplying 180 degrees on top, pi on the bottom. I'm going to cancel out the pi's. I'm going to say 3 goes in here once and 3 goes in here 60 times. I have 5 times 60, which is 300 degrees left. And I want to know, what's the reference angle for 300 degrees? Again, you don't have to draw the picture, but let's think about this. 0, 180, 360. And even without drawing it in, I know that 300 is closer to 360 than it is to 180. So I'm thinking about 360 minus 300 will give me, that's a 60 degree reference angle. Now, 5 pi over 3 might not be the first one that comes up with a 3 on the bottom, but it doesn't matter if you get those out of order. It'll still work for you. In fact, if I come back to here and look at number 3, 2 goes in there once, 2 goes in there 6 times, 2 goes in there once, 2 goes in there 3 times. There's another one with a 3 on the bottom. So that's another one that would go into this pi over 3 space. Multiply by 180 degrees over pi. Cancel your pi's. 3 goes in here once and 3 goes in here 60. This one turns out to be 60 degrees. If I look at my drawing, 300 degrees was down here somewhere. And 60 degrees is up here somewhere, but it's also 60 degrees away. I talked about this a little bit in the notes before. I talked about the fact that the ones that I had colored in the same color when I was making up the numbers on my circle had matching reference angles. 300 degrees and 60 degrees were some of the ones I had in the same color. Basically, I want you to notice that everything that has a 3 on the bottom, you'll have to see what the other two are and work them out, is going to end up with 60 degree reference angle. I want you to work them out and verify that that's true so that you know you've done your multiplication correctly, but it is going to be true. What's the other one I haven't put over on the right yet? 7 pi over 6. Let me go to my next page because I know the ones with denominator is 6 over here. Denominator of 6. I'm going to put in 7 pi over 6. I'm sure that's not the smallest one with a 6 on the bottom, but that's okay. As long as I get all of them into this space, it doesn't really matter which one I put down first. And this is 180 degrees over pi. And I want to cancel my pi's. And I want to say 6 goes in here once and 6 goes in here 30. So I get 7 times 30, 210 degrees. If I think about the reference angle for 210 degrees, if this is 180 and this is 0 and 360, I'm going to say, is 210 closer to 0 or 180 or 360? Even if I haven't drawn it yet, I know it's going to be over here somewhere. If I was actually required to draw that, I would be more careful about that drawing. But that's 270. So I know it's closer to 180 than it is to 360. So I'm just going to think about 360 minus 210. Which I don't know why I used 360 when I said it was closer to 180. Let me write that back again for a minute. What was happening here was I was getting 150 degrees. And I know that a reference angle is never bigger than 90 degrees, so I knew that I had made a mistake. It has to be closer to 180 than it is to 360. So I'm going to say 210 minus 180 gives me 30 degrees. This one has a 30-degree reference angle. Let's come over and do some from this section. This section is 1/8. And if you took 360 degrees and divided it by 8, you'd be cutting it into 45-degree sections, or pi over 4 sections. Let's just do this first one, number 14. I'm going to say 2 goes in here once, 2 goes in here 4. I have pi over 4. And when I get ready to bring it to the right-hand side, that will be pi over 4 here. Trying to change it into degrees. I want to get rid of the degrees. Get rid of the radians and make it into degrees. 180 degrees over pi. I'm going to cross out my pi's. I'm going to say, I know 2 goes into 180 90 times, and I could do it in 2 steps, but 4 goes into 180 45 times. So I end up with 45 degrees. And if you were looking at a drawing, 45 degrees would be right there. The distance to the nearest part of the x-axis would be 45 degrees. Let's do another from this section. Uh-oh. Did you see what I did? This turns into 0 pi over 4, which is really just 0 degrees. So I can't really call that one pi over 4, can I? That's kind of 0 radians. 0 radians is equal to 0 degrees. 0 radians. So that would be denominator 1. I'm going to come down here and say 0 over 1 times, pretend it has a pi in it? Yeah, it kind of does. If I multiplied that by 180 over pi, and this is the one where I could say, you don't have to show me any work because 0 times anything is still 0. And how far is it from the nearest part of the x-axis? 0. Okay. Somewhere in here there's one that actually is pi over 4. It's this one. 2 goes in there once, 2 goes in there. This is 1 pi over 4, which is pi over 4. this is the one that actually belongs up here in this space. Get another one. How about number 18? Let's do a little cross canceling. I'm going to up and down cancel first this time. 4 goes in there once, 4 goes in there twice, and then a little cross canceling. The 2's cancel. This one turns into pi over 1, or just plain pi. That's another one that goes down here. Multiply by 180 over pi. Get rid of the pi's. That's 180 degrees. But reference angle is not 180 degrees. Reference angle is the distance to the nearest part of the x-axis. If you're at 0, you're 0 degrees away from the nearest part of the x-axis. If you're at 180, you're not 180 degrees away from the nearest part of the x-axis. You are right on the nearest part of the x-axis, so you're at 0. Let me see if I need to do one more of those. How about number 20? I'm going to up and down cancel first. 2 goes in here 3, 2 goes in here 4, and then I'm going to do a little cross cancel. 2 goes in here once, 2 goes in here twice. I end up with 3 pi over 2. 3 pi over 2. I'm looking for things that have a denominator of 2. Looks like I'm going to have to go back to the last page. There we go. Things with a denominator of 2. 3 pi over 2. Cross out the pi's. 2 goes into 180 90 times. 3 times 9 is 270 degrees. And if we looked again at this 270 degrees all the way down to there, it's another one of those 90 degrees to the left, 90 degrees to the right, 90 degrees for the reference angle. Okay, I think I did quite a bit of that for you. But I hope you're starting to realize that the reference angle, if the denominator matches up after it's fully reduced, then the reference angle will also be the same. I have had some people stop and think that this one, for instance, was 10 pi over 6 and try and put it into the section with 6, and then it didn't match up. So you know that if the reference angles are not turning out the same, that means something's wrong. You didn't fully reduce your fraction, or you reduced incorrectly. Okay, I think that's enough to get you through. I think I've done quite a bit of that for you.